This week you will perform a TLC lab of common analgesics in an unknown mixture. TLC is thin layer chromatography. It is used for a number of things. First, it can be used to identify the number of components in a mixture. Based on the number of spots, you can determine the number of components, and you will see this with your unknown. You can use TLC to identify unknown substances by comparing the migration patterns of a known and an unknown. You can monitor the reaction progress by comparing the migration pattern to your reactant and to your product. And you can use it to assess the purity of a substance. If a substance is pure, you will only see one spot. These are some TLC terms. You have a stationary phase and a mobile phase. The stationary phase can be referred to as your adsorbent. This typically has an alumina or silicon coating on a sheet of glass or plastic. The TLC plates we use have a silica coating. You then have a mobile phase. This is your eluent or a solvent. The solvent choice is important to make sure that you have a proper separation. So if your substance is to be separated or polar, your solvent should be slightly less polar. And if your substances are nonpolar, your solvent should be slightly more polar. This is an example of your developing chamber. So you have a beaker, you have your eluent in the bottom, you set your TLC plate inside of it, and you put a watch glass over the top of it. When you set your TLC plate into your developing chamber, you want to make sure your spots are above the liquid. Otherwise, your substances will dissolve in the solvent, or they may run in the reverse direction.
In order to prepare your sample, you are going to add a tablet to a mortar and pestle and crush it. You will transfer the powder to a test tube, add 10 milliliters of ethanol, and swirl it to mix it. Not all of your powder will dissolve as there's starch and other binding agents in there, but you need a little bit of the tablet to dissolve so that you can spot your plate. After you've transferred the powder from each tablet into the test tube, you want to clean the mortar and pestle out. These are slightly porous, they do have stains in them, so just do the best that you can. You need 2 TLC plates. The plates you are using are coated with a silica gel. A few centimeters from the bottom, you're going to draw a line using pencil. On one of the TLC plates, you are going to put 3 dots and try to space them evenly apart. Make sure they don't get too close to the sides. On the other TLC plate, you will put 2 dots, and you can just put them in the middle, about evenly spaced apart. You want to label the dots below the line using a pencil. We're going to label these for each drug. So we have aspirin, acetaminophen, and caffeine. In order to prepare your plate, you are going to use an open-ended capillary tube. This is just like your melting point capillary tubes, it's just open on both ends. You will stick it into your test tube that has the ethanol in your tablet, and you will spot. And in order to do that, you just dab the dot. You will repeat this using a new capillary tube for each substance that you have. And now you're going to wait for this to dry completely. Once this dries, you will no longer see the wetness, but you will be able to see where you spotted it. You can see that the spots have dried on the TLC plate. So you are now going to put this into your developing chamber. I've added about 7 milliliters of an ethyl acetate acetic acid solvent. I'm going to set the TLC plate into the developing chamber, put the watch glass on top. You can see the solvent is rising up the TLC plate. This is through capillary action. We have the watch glass on here in order to saturate the chamber with these vapors and also to prevent evaporation of the solvent. At this point, you can see the solvent has risen about 75% of the way up the plate. You're going to take the watch glass off, pull the plate out, and immediately mark your solvent front. We're going to use this to calculate a retention factor. Once the plate has fully dried, you will look at it under a UV lamp and you will circle your spots. I only spotted this plate with 2 substances, and you will just circle the spots that you see further up the plate.
Looking at the migration of your spots on the TLC plate, we will see that nonpolar substances will travel further up the plate than polar substances. Your dominant interactive force between the silica gel and the analgesic is a dipole-dipole force. So the more polar substances interact more strongly with the silica, and they will not travel very far up the plate. Your nonpolar substances will not interact strongly, and you will see that they've traveled the furthest. So this is your structure for the silica gel. You can see that polar substances will interact more strongly with this than nonpolar substances.
Once you have circled your spots, you will measure the retention factor, which is just a ratio of the distance the spot migrated to the distance the solvent migrated. You will measure from the middle of the spot to the line. That is the distance your spot has migrated, and the distance of your solvent front is from your line where your solvent was when you removed it from the developing chamber.
Once you have measured the retention factor for each spot, you can determine the components in your unknown by comparing the retention factor values. At the end of the lab, you want to keep your TLC plates and place them in your notebook. In terms of safety, as always, you want to make sure that you are wearing gloves and goggles throughout the entire lab period, and ensure that you wash your hands before you leave. Any of your ethanol solutions can go in the drain. The ethyl acetate acetic acid solution will need to go into the organic waste beaker, and any additional solid waste that you have from the tablets can be placed in the trash. Next week, this lab report will be due, and a video will be posted on PAL for the next lab, which is a SN2 lab.